Hi everyone. So we've got quite a lot to cover today. This is going to take a while. So this lecture, video, whatever you want to call it, is going to have a lot of stuff going on. If there's weird noises, there's not a lot I can do with that because they're demolishing the building outside. There's a dog barking, there's cars going past, but that's how it is, I guess. All right, so there's a bunch of things we need to do. I'm here in my editor and I'm in the me folder. You can see that because I've just got the me stuff on the side and it says me here at the terminal. So what I want to do first off is to pull down the latest version of the course content because there's a new folder in there that we're going to need. So I go cd ... course, and now I can see I'm in course, and I say git pull, and it pulls it down. Now mine is up to date because I just pushed from my computer to the repo. Yours will pull down a whole bunch of new stuff and then you'll have it in the course. Okay, so then we want to go back to me, cd ... me, and now you're kind of set to do things. Okay, now you've got the new course content, but we're also going to make a new repository for your data project. So you go to github.com, make sure you're signed in, you'll be able to see your little face up there. You say new, and then I'm going to be the owner here, make sure you're there, and we'll call that data project. And I'm going to put a number on this. You don't need to because you're only going to do this once, but I don't want to clash this with next year. Like that. Okay, now we can put a description in here if we want. Code 1161. Like that. And let's add a git ignore for Python. And we'll add a README file. And we can do this stuff a bit later. It's probably a good idea to add a license. Let's add an MIT license. And then when we click create repository, it'll make a new repo for us. Here it goes. It's got a git ignore, it's got a license, and the git ignore contains a bunch of things that sometimes come up in Python folders, but we don't want to take them. So we just basically ignore all of these things. You don't have to worry too much about what it's doing, but it's just a very useful thing to have in your folder. You've got a license, you've got a README. README is this file here, so it says this is my project, this is what it's about. So it helps other people look at it. Okay, so we're in this situation now, and we want to clone it down to our computer. So click the green button, click the copy, then go back to me. We go cd ... so we're in the parent folder, and then do a dir if you're on Windows or ls if you're not. Now there's more in my folder than will be in yours because I've got the course and I've got all of your repos and all that sort of stuff. But we're in the base 1161 folder. We go git clone, and then we'll paste in that link, press enter. We're cloning into Data Project 2021, and now we've pulled that down and we want to cd into Data Project 2021. Now we're in there, okay? So we've got a folder for our project, and there's nothing in there just yet. So now we want to say code .-r, which means open VS Code, which is what we've got in the window we're in right now, in the folder we're in right now, sorry, and then reuse the window that we're using. I'm going to do a little flash, and there we go, we're in the data project folder. So now, if we right click on any of these files, we can say reveal in File Explorer. And so now I've got my files here, and if I open another one, which I happen to already have open, here is the 1161 folder. So you get two finders open or two explorers open, and we want to go to course, and in data introduction, let's just, for the sake of argument, take all of this stuff and copy it. So we can right click on it and say copy. And then we want to go back to here and right click and say paste. So now we've got all of those files in our new repo. So if we go back to VS Code, we'll see that we've got all these new files. You can tell they're new because they're green. There's a file over here called basic pandas, IPYNB. Now we've been working with .py files, Python files. This is an interactive Python notebook, which is a bit of a mouthful, but let's have a look at what it does. We can get rid of the terminal as well now. So this is more of a data sciencey way of doing things, but you'll see a lot of people using these because they're a very nice environment to work in, but they can be a little bit confusing for a few reasons. So let's zoom in a bit and have a look. Now, the important thing here is that these files need to run from top to bottom in the same way that a regular Python file does, but they're made of cells, and the cells can run in any order as long as the cells before them have been run, if that makes sense. So the order of top to bottom is kind of up to you in however you run these things. So the thing that's magic about notebooks is that you can mix markdown text, which you've been writing in your lab books, with Python. And so this notebook takes us through importing a data set, working with it, but also has some notes about it and some things that you can do in a notebook. So this cell here is a markdown cell. So if we double click it, we can see it's got a hash for the title, blah, blah, blah. It's got the underscores for italics. And if we press Control Enter or Command Enter, it will run that cell, which in the case of markdown, running just means rendering it. So if we want to have a look at the data set that we're working with, it's this one, which actually is CSV, it'll download it, so let's not do that. Okay, so we're going to go through and there's a bunch of things that we need to do. Now we've seen importing things before, so we're going to import some things. Now we haven't really talked too much about why we're importing things, so let's talk about that now. When we import something here, which we call in Python, this is a package, then we are asking for some code from another file that someone else has written. So when we say import matplotlib, we're importing the whole of matplotlib to be able to do stuff with it. Same as we're importing numpy. Now when we have as, it means we can treat numpy as we're aliasing it to np. So instead of having to write all of numpy out, which we can write np, which sounds like it's not that much of a saving, but it's kind of a convention that in the sort of data-y world that np and pd are the acronyms for, not acronyms, abbreviations for pandas and numpy. So here are our inputs. Let's run them by clicking the little play button here. And we get a number. Now, I've clicked a bunch of things in this before, but this tells me this is the fourth cell to be executed. You'll probably get a 1 when you do it. So we keep coming down, we'll click play here. And this is just some magic that tells it to put the graphs in line. Because this is we'll see in a second what we end up with. So there's just a couple more things to click. We're going to set a saved style so we can go back to it. Don't have to worry too much about this until we get to the bottom where you'll see why we've done it. And then this bit of code here loads the data. Now, we're going to use this PD read CSV to load the data. And there's a bunch of things here that we need to talk about. So the first of which is this this chunk here, which is doing two things. One is that it's checking if we have the file or not, and then it's setting where we load it from. So the OS path is file. OS allows you to interact with the operating system. Path is for doing path type things like file path, so c/files/callfile.txt or something like that. And then this is the file path that we're checking for. Now, if we do have that, we'll set the file path to be our local copy of that, which is great. And if we don't, we're going to go and get it from this URL. which is the link to it on the internet. And pd.readcsv can do that. It's quite clever. It can do internet stuff and local things. Now, what are we dealing with here? So PD is the module Pandas that we imported a second ago. And Pandas is this very powerful data analysis language, data analysis package that sits on top of Python, and a lot of people use it. It's incredibly popular. And then readcsv is a method. And we've used lots of methods before, but we haven't really talked about what it is. So a library or a module can contain, basically it'll contain methods or properties. It'll have classes as well, but we'll handle them in a second. And so readcsv is a method that we're pulling out of the Pandas thing. So you can imagine Pandas being like a box, a toolbox, and readcsv is one of the tools. And then it basically works as a function. It basically is a function. And so we give it the file path, which in this case we're going to set as one of these two things, and then it'll load it. So when we run that, it'll say, okay, loading from file, done. And you see the couple of seconds between loading from file and done, that was the time it took to load that data set, because it's a lot of data. Okay, it's like 50 megabytes of data, and it takes a little while to load. It'll take longer if you don't have a local copy. All right. So the first thing we want to do is have a look at this data. And so let's run this one. And we see it's basically a spreadsheet because it's come from a CSV, so it has to be a spreadsheet. And so we can scroll around here and we can have a look at what's in here. There's lots of like gaps, and nan means not a number, which just means empty basically. And we have all the column names. So offense financial year, offense month, offense code, all that sort of thing. And so head, we can say, give me head 2, and that will give us the top 2 rows, or we can leave it empty and that will give us the top 5 rows. So it's good to have a look at this. A lot of what we're going to do here is summarizing the data, looking at it, and just getting a sort of understanding for it. You could do this by opening the file in Excel, but there's some nice tools in here to give you what's going on. So let's have a look at what the columns are in here. So this gives us a list of the columns, so we can have a look. So not all of these things are not super obvious. So I don't know what sins ind means or food ind means. That gets complicated. So we need to go beyond the data set and like actually understand the context of this, where it was collected, why it was collected, who collected it, who paid for it, all that sort of thing. But sometimes we can get an idea of what's going on by looking at the data. So let's have a look. So let's get into this and see what we can do with Pandas. So imagine we've got this big grid of data. If we want to get the first row out, we can't just say penalty data and then square brackets 0, because that will give us something unexpected. I think in this case it will give us a column, but we want to get the first row, in which case we need to use the iloc property, and that gives us back the first row. It's a bit like a dictionary. So it's very similar to a dictionary, but it's actually called a series, which is a Pandas object. It's like a dictionary, but it has lots more that you can do with it, which is pretty cool. So we can say, okay, what's the financial year? Okay, it's the 11-12 financial year. And in one of these cells, we don't need to print the last thing that it shows. So if we just type row 1 after that, so we assign row 1 to be the contents of the first row, or actually the 1th row, so it's actually the second row. And then row 1, when we just write that like that, prints this out, and we can have a look at it. Okay, so none of these things are actually relevant. This fine was for $265 for stopping on a crossing. So that's naughty, according to the Road Rules 2008 laws. Right. So if we want to get into this further, we can treat it basically like a dictionary, and we can use a square bracket indexing into it. There are, however, extra cool things that you can do with this, and you can treat them a bit like an object themselves. So we can say row 1, and we can let auto completion finish this off. And okay, it's not going to do it, so I'll just paste it. So we can treat it like that, and it gives us the same answer. We can do both. So it's up to you which you choose. Sometimes you have to do it this way if the space is in it, or if you want to use a variable, but this is sometimes just a bit nicer in terms of readability. It's not as many characters, you save 4 characters. All right, So if we do the same thing on the whole data frame, the whole grid, we can get a whole column out. So this shows us the value of the column. Now, that is truncated because there are 200,000 rows in that column. We don't want to see all 200,000 columns because that's a lot of rows, because that's a lot of scrolling. So we've got all this data, and let's plot it. This is going to be our first plot. It's very simple. We just say, take this thing and plot it. Now, this is very difficult to understand. You can kind of get your head around it a little bit. You can see that somebody got a $17,000 fine, blah, 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 but it doesn't really tell you very much because this plot is just way too dense to be useful. Okay, so we just say, take the column and plot it. But columns tend not to be very usefully laid out. They're usually laid out in some other way. So we're going to use a histogram. And a histogram uses what are called bins. So this is one bin. So any value, any fine value between 0 and, I don't know what that is, let's say 1,000, goes into that bin. And then any fine between 1,000 and 3,000 goes into that bin, and so on, right out to 17,000. What we can see is we get this very steep drop off. And so we want to do some exclusions. So what are we getting at here? We have to use a Boolean mask. So if we look at this, let's just do it and we can see what we get. So we can now see that we're only dealing with fines up to 3,000. So this 3,000 is this 3,000. So let's break this down a little bit. So penalty data face value is the it's the column that we're dealing with, and we can also do that like that. And then we're indexing into that column using this statement. Now what this produces is a Boolean mask. And let's get into what a Boolean mask actually is. So we could do it like that too. Depends how you like it. This is basically an aesthetic decision. This is one of the things that's interesting. People talk about programming as if there's a right and a wrong way to do it. You can do it in all sorts of different ways. You just have to make your mind up. All right, so Boolean masking, what are we dealing with here? So we want to make a new series. So we say pd.series with a capital S because series is a class. And let's have a look at what we've got here. So the first 5 numbers in this series are 0 to 4. Now, this on the right is the values, this on the left is the index. We can talk about that more if you want, but it's not super interesting. So there are 100 values in that series. But if we want to use a Boolean index for this, we can just say some numbers less than 8, some numbers where some numbers are less than 8. So this makes a mask. So if we run that, we just get the values from 0 to 7, because these are the only values in that data set that are less than 8. And we can also do some other more fancy things. So this is an OR operator. You can't use the OR operator. I'm not sure why, but it's just a kind of Pandas-y thing. And that gives us all the numbers that are bigger than 97 and smaller than 4. Or all smaller than 4, sorry. So let's see what we can do with this in a kind of more interesting way. Let's tidy this up a bit because it's going to mess with my OCD. So this is a list of pets. These animals are pets that you can keep. I think I got it from Wikipedia. You can use any list you like, it doesn't matter, but you know, might as well use this one, it's less work. All right, so we look at these words. They're strings, right? So they're all strings. Some of them have capital letters, some of them don't. I don't know why, but we want to turn this list of pets into a series. So we're going to say pet series equals pd.series pets. And so we just take a list and we convert it to a series. Then our pattern of bools is this, and this is a list comprehension. So we're going to talk about that in a second. So let's just see what it does. we want to print the pattern of balls, and we want to print then afterwards, because it's the last thing in the cell, we're going to see just what we get when we mask it using that thing. So this is going to give us just the pets with an O in them. So let's run that, and we see that we get a whole bunch of pets, because lots of pets have O's in them. We can rerun that and just change it to, I don't know, pets with an N in them, like that. Okay, so what's happening here? So we get this this is the pattern of balls. So let's make that say pattern. Oops. So we know what we're talking about here. So this pattern of Booleans is a mask. So there's the same number of Booleans in here as there are pets in here. So we can see pattern here is false, false, false. So dog doesn't have an N, goat doesn't have an N, pig doesn't have an N. And we keep going with these falses until we get to a true. And our first true is chicken here, which does have an N. And if we want to make that really clear, what we could also do is just make a little zip on here. I think this will work. Fingers crossed. Oh, we have to expand it. So now if we look at this, we can say, okay, so let's look for a true guinea fowl. Yes, that does have an N. And so that's, as we pair these things up, we can see, okay, false dog, false cattle, false zebu. Let's look for a true guinea pig. Yes, there's an N in there. And we can change that letter to, let's say Z, and only one thing, the zebu, will have it. So that's kind of cool. So, it won't have it because it's a capital Z. So Z, zebu. So let's go back to N and take this stuff out just because it's a bit confusing. All right, so we have our mask, which is this list of Booleans. That list of Booleans is here, and we're using that as a sieve, like a filter, and we call that a mask, and it masks this series, and so we only get back the things from that series that have an N in them. And so there's a bunch of things happening in this list comprehension. We haven't done list comprehension, so I wanted to hit them right now. So if we remember from last week and the week before, we were using this pattern. We say pattern to mean a kind of structural idea that we use over and over again. So we have a container or a collection or bucket, as I sometimes call it, and we loop over a list of something, and then we test it, and if it passes, we put it in the collection. If we don't, we just throw it away. So this is 4 or 5 lines of code. We run it, and we can see these are the 4-letter pets. So that's a lot of code, and we do this so often that Python has a built-in magic way of doing it. So let's go through this kind of very simply. So this is a list comprehension. It's in square brackets, staples. So we just say, do this thing, P, for every P in the collection pets. And so if we run that, we get all the pets back again. So that's not actually very helpful because we want to add some extra bits and bobs to it so that we can make it actually do something rather than do nothing. So if we wanted to get all the pets in uppercase, we can say p.upper, which means do this thing to this P for every P in pets. Now we've got all of these characters, which is good. But sometimes we want to add a conditional statement to that. So we can say for all the P's in pets, if the length of P is 4. So great, we get them back. That's working as a filter. And if we wanted to do something to the filtered results, we'd say p.upper for all the P in pets if the length of that P is exactly 4. So we could change that to 5, and it gives us all the 5 character things. So that's super powerful, and it's super terse. Terse means short and easy to understand in this case, not stroppy and angry with you. So if we go back to where we saw our thing here, what we're saying is we want a Boolean check that checks if n is in X for each X in the pet series. Now we could change that to pet name if we want it to be good and self-documenting. That's probably a bit better. Okay, let's move on to what we can do with that now. So what we're doing with this thing is we're saying we want this Boolean mask, and this Boolean mask comes up much more easily because we're doing it magically with pandas. And we just want the values where the face value is less than $3,000. So that gives us the plot of just the sub $3,000. We can still see that most fines are under $500. So what about the fines just under 1,000? We can have a look at that too. Okay, now it's starting to get a bit more interesting. We can see that most fines are either like relatively cheap or around the sort of 250 mark. And we can come back to that in a bit, so let's have a look. So what's happening in the legislation column? So if we think about this, let's put in a new thing here, and we can say penalty data dot head, and let's just look at what types of things are in these columns. So we've just been looking at face value. Face value here is a number column, so we would call that continuous. If we look at the legislation column, which is this one, that's a string. And so what that tends to be called is categorical. So this is a continuous value, whereas this is a categorical value. And we can't draw a graph of a categorical value because it's not a number. It doesn't make sense to draw graphs of that. But what we can do is turn it into a number. We can make a number of the count of each time that shows up. So value counts produces this nice list of it's a series again, and the index is the thing that we're counting, and then the value is the number of times that shows up in the data set. So in this case, there's 50,000 fines in that data set, and the legislation column, if we count the road rules 2008, we get 100,000 of those. So what we can then do is we can plot that, and we say we want a bar chart because otherwise we get a line chart, which is kind of useless for this. It'll take a while because there's a lot of them. It takes a long time to draw that huge amount of text onto the canvas. We can see there's a whole bunch going on, but we can't really see because it's too crowded. So let's put in an extra thing. So we're going to declare an extra variable, so we can do this in 2 steps. And then we're going to say, just give me the things in that list where the value is greater than or less than 5,000, sorry. So this is just the unusual ones. So we're kind of getting into the weirder and weirder things. So there's a fair bit that's less than 5,000. But that number there is 20,000. So it's going to be the stuff from kind of here onwards. So let's have a look at that. Still super crowded, but we're looking at things under 5,000. So what if we look at the stuff from here down? We're into 1,000. All right, here we are. So still way too crowded to be able to actually read it. What about 100? So this isn't giving us 100 things. This is giving us any offense category with less than 100 things in it. That shows up less than 100 times. So it gets rarer and rarer. So 100 is probably from here onwards. So here we go. Now we're starting to get more visible. So the Australian Consumer Law Act, New South Wales, occupational health or something or other. So interestingly, this is starting to fall off quite nicely. What about the last 10 things? Here we go. So it's not 10 things, sorry, it's the last last little bit of the tail that shows you the last 10. So we're getting sporting venues authority regulations, food regulations. Not many people have been fined under these things by the traffic cops, basically, is what we're saying here. Now, these plots are a bit bad. They're not good plots. They don't have labels, they don't have titles, the colors are a bit naff, all that sort of thing. So we can talk about how we're going to do this. So, okay, so we're just going to make some random numbers, and this is a way of doing that. It's basically saying, let's make a normal distribution of random numbers using the rand norm thing. If we hover over it, we can see the docs for it. It's pretty good, actually, the NumPy documentation. So standard normal distribution. And let's just see what we produce, and then we can talk about it. So here's our graph. It's a histogram of some random numbers. It should look basically like this, but it's creating random numbers differently every time. So yours might look ever so slightly different. But we're starting to see that we've got a bunch of things for it. And we use a different method of plotting. We're using matplotlib more directly here. And so we're saying, we're using the histogram. So if we hover over that, we should get the docs, which is sort of difficult to tell actually from here. But on the matplotlib website, you can have a look. They've got very good examples, and that's actually linked just here. Let's have a look at that. So here's the example. Looks very nice. So what are we looking at here? So we've got an X label, we've got a Y label, we've got a title which uses LaTeX in this case. So this X is a kind of, I don't know if it's an insider joke or something like that, but it's a chi in general speech. So people say LaTeX with a K rather than latex with an X. And we are now showing a grid, say yes, and then we say plot.show. Plot.show in Notebook is actually not necessary, but you can leave it on anyway. It doesn't make any difference. So now we've got a title, and that's much better. It's a much better plot. We can show it to people. It's self-explanatory what's happening. So we made our plot look like this by using the .hist method on the data frame that we've got. That comes from Pandas. But if we want to put the Pandas data into Matplotlib rather than kind of using Matplotlib from inside Pandas, which is a kind of flip on things, we can just change it around a little bit. So we're going to make a new data frame. So that makes a new data frame. And we're going to put it into this variable, capped face value data. So it's capped at 1,000. So now we're just going to say, take this data, please, and plot it as a histogram. And so they look pretty similar. There's some defaults in the Pandas one that aren't coming through in the Matplotlib one, but that's kind of down to us to figure it out. So you can have a look at the docs here on that link. So let's show a couple of things. We can plot two things on the same graph. So what we're looking at here is the green are the distributions of the values inside the blue bars. So we have 50 bins in the green ones and only 10 bins in the blue ones. And so we've got a color, the blue, alpha 0.2, alpha 1 is, alpha means transparency. And so these things are reasonably self-documenting, which is pretty nice. So we've got a better graph here. We can sort of see things going on here. So lots happening inside this, but it's mostly hard up against the right-hand side. I mean, I don't know if this is super necessary, but it works. So let's have a look now at our histogram of all the fines. So what we see here is that there's the vast majority of fines are pretty low. And if we want to see that in a bit more detail, we don't necessarily have to use any kind of magic stuff. We can use the plot itself to hide the bounds. So if we run that, we can see that we're cropping the range from 0 to 2000. It means we don't have to do as much data manipulation. So let's say we're only interested in the stuff under 1000. it's just going to be a bit quicker because all it's doing is moving the window of the plot rather than actually manipulating the data. So we can do the same thing here, lower bound, upper bound, just make that a little bit more readable. And it should look exactly the same. Yes, it does. Magic. So what all properties can we have here? So we want to put a title, that's good. So if we want to do a nice graph here, we can do a histogram. The first thing we do is actually plot the histogram. And then we can add a title, X and Y labels, and we can say, yes, we want to show a grid. So if we have a look at that, then we get this graph here. Now these axis labels are way too big, but it just shows that you can change them in your code, and we can make it way too small as well. So that's up to you to have a little play with. So we've got our dates here, which we're just guessing as then and now, which is kind of silly. We want to pull them out and actually get real dates. What we're going to have to do is import the data again and tell it that we want to turn some of those dates into dates. And so one of those things is the inferred date time option. And then we can also say explicitly we want to parse particularly this column, definitely. And then day first is just to protect us from the kind of American silliness of putting the month first. So let's re-import that data and have a look. So we're overwriting the original data, so it won't make any difference. If we have a look now, we can see offense month is being interpreted as a date. And so what that means is we can do a bunch of very clever things with this group by concept. So we want to see our monthly income from fines. So there's a lot going on in this graph, so let's talk about that a little bit. So the first thing is we're using the XKCD plot style, which is a kind of built-in magic thing that just says, when you ask for this, set your plot to be this style. Then we're going to plot the income value using the X dash line style, which means put an X at the junctions and then a little line between them. We're setting the title, which we've done before, and we can now see this stuff. Now group by is a super powerful concept, and I'm going to come back to that a bit later, but just be aware that it's a really useful thing to do. Now, this one here will just set us back to the regular style, which is nice. All right, a couple of things that are useful to do. So these, I kind of call them tricks. They're just things that are nice to have. So this is slicing. We'll get into slicing a bit later, but basically it just allows you to pull out not a particular thing out of a collection, but a range of things. So now we've got the first 5 rows out of things. So we can do something complicated on those first 5 rows rather than having to worry too much about having to run it over, say, 100,000. So just making a new column here. So what we're saying here is we want to make a new column called day, and we want to use a lambda function to pull out just the day of that. So if we go along to here, we're seeing we're getting day 1 because that's a Monday. Now, what is happening with an apply? Let's have a look. That's the same as saying we're going to make a new function that returns the value, the day component of that value that we'll be giving it, and then we're using the function here. So lambdas are basically a way of doing an inline function. I'm not a big fan of lambdas unless it's something very, very simple. I would much rather be explicit and make a little function, but some people will do it, and so I just want you to see one in action. Okay. The other thing we're going to have to deal with a lot is is like data sets that have more than one way of representing the same stuff. So, for instance, you might see all of these different ways of representing UNSW showing up in a data set. We want a way of being able to pull in that data set without messing around with it in Excel and converting them all to a single canonical value. And so this is a pattern that I use quite a lot for cleaning things up, which means you try and you get the value, and if you can't get the value, then it will give you something like regular back. And so we add this, we build this big dictionary of mappings between one thing and another. And then when we run that, it says, well, when we give it New South, it prints Uni of Stairs. And when we print Bedo, it prints Ben Doherty. Now, this has been a lot of stuff in this notebook. So I want you to work through the notebook, and I want you to kind of come to me and say, like, this particular thing doesn't make sense. And if it doesn't make sense, I'll make another video just on that particular thing. Play with it. There's a lot going on here. So you've got a whole week to get comfortable with this. And the idea is that you take this file, and instead of it running this penalty data, you can run your own data through it and use this as a jumping off point to get your data analysis working. So copy this file again and make it be called My Data Project or something. And then just start running your data project through it and doing a bunch of the exploratory data analysis work in the data audit section of last week's homework.